Chapter 3, Section 1. In this section, we are going to study functions. There are 5 objectives in this section. We are going to look at it one by one. First, let's look at how to determine whether a relation represents a function. So this is a linear equation, y equals 3x minus 1. And we want to know whether this represents a function or not. So first we need to understand two definitions. What is a relation and then what is a function, right? Relation refers to the correspondence between two sets of data. Okay, for example, one set of data is x, the other set is y, and then relation describes, the correspondence between these two sets of data. Okay, like if x equals 1, y equals 2, right? If x equals 2, and then y equals 5. So this linear function describes the correspondence between these two sets of data, right? And then we can find the value of x, and then we can find the corresponding y's. So linear equation describes the correspondence between two sets of data. Now what is a function? If let x and y be two non-empty sets, okay, the two sets of data, they're non-empty one. A function from x into y refers to a relation. Okay, so first of all, function is a relation. But it's not any relation is a function. Function is a special relation. Okay, how special? The relation that each element of x pairs exactly one element of y. Okay, if relation of the two sets of data, okay, each element of x pairs exactly one element of y, and then we say this relation is a function. Okay, that's why we say function is a special relation. So let's look at this linear equation one more time, okay? See if every element of x pairs exactly one element of y. If x equals 1, y equals 2, right? X equals 2, y equals 5, and then x equals 5, y equals 14, right? And then this can goes on forever. So we do see is one from x, one element of x pairs exactly one element of y. All right, so this linear equation is a function. Okay, this represents a function. What about this map? Okay, left hand side is the state, name of the state, right hand side is corresponding number of representative. So let's see if every element in x pairs with exactly one element in y. Alaska, right, have 1 representative. Arizona have 9, right? And then California have 53, Colorado 7, Florida 27, North Dakota 1. So one element in the state pairs exactly one element of its number of representative, right? We don't care the y have a repeated value or not. We only care whether one x pairs exactly with one y or not. So that being said, what we need to look at just the left hand side, each element, how many arrows going outside. If only one element going outside, and then this relation represents a function. Okay, so the answer for this example, yes, this relation is a function. So let's try next one. The x is the name of a person, right? Y is corresponding phone number. Okay, let's see. Don has 1 phone number, and then Gizmo have 1 phone number, But Colleen have 2 phone numbers, right? You see this 2 arrow coming out of from one element of x. So that's why this relation is not a function, right? One x pairs with 2 y's. That's why this is not a function. Let's see this one. Animal and its corresponding life expectancy. So let's see how many arrows coming outside from each element of x. 1, 1, 1, 1, right? So we don't care whether y have repeated value or not. We only care whether x paired just with 1y or not. So this is a function. This relation represents a function. So that's the definition of a function, okay, which is I stated earlier already. Let x and y be 2 non-empty sets. A function from x into y is a relation, okay? Is that right? First is a relation that associate with each element of x exactly 1 element of y. Okay, 1 pair with exactly 1. This kind of special relation is called a function. Okay, that's the figure represent the function. So 1x pair with 1y, right? This is different x pairs with 1y. We don't care whether y are repeated or not. 1 element of x pair with 1y. And then here we have 2 new concepts. Okay, need to introduce. One is called a domain, one is called a range. So what is a domain? Domain is all the value of x. Okay, the collection of all the elements of x is called a domain. And then similarly, all the value of y is called a range. Okay, so you can see if this relation is a function, and then the number of elements is in the range could be less than or equals the number of elements in x, but will never more than, right? Because x pairs with exactly 1y, but we don't care y is repeated or not. So that's why we could have repeated value of y. That's make the number of elements of y could be less than x, but will never more than x. If more than x, that means 1x pairs with more than 1y, right? So now let's look at the example. Determine whether a relation is a function. Okay, so for each relation in the figure 6, 7, 8, state the domain and the range, then determine whether the relation is a function. All right, let's look at A, figure 6. Left-hand side represent calories, right-hand side is the fat, okay? The fat contents in grams. So what is the domain? Right? Domain, remember, is all the elements in x, right? So by the way, how you know the calories are x, the fat is y? Because the arrow, okay, is the relation, from x into y, right? So domain is all the elements of x. So we use set notation to represent. Okay, what is a set notation? A pair of braces, and then each element we use comma to separate. Okay, so we have 580, right here, and then 650, 541, 550, and then 700, and then close braces. Okay, that's how to represent the domain. And then range, also use set notation. 31, all the elements in the y, right? 37, 33, 29, and then last one, 43. Okay, that's how to find the domain and the range. Put all the elements of x into a set notation. that's the domain, and then put all the elements of y in, that's the range. And then whether this is a function or not, so we're gonna see whether each element from X pairs exactly 1y, right? It is pair exactly 1y. So yes, figure 6, this is a function. So let's look at figure 7. Left hand side, okay, is the gas station, that's X, and then price per gallon, that's the Y. So we can determine X and Y because the arrow, okay, is from X pointing to the Y. So is this a, let's see, the domain and the range first. Okay, let's find the domain. Domain of B are the elements, okay, in X. That's all the gas station. Okay, that's the domain. And then what is the range? All the gasoline price. So you see the number of elements in Y. For this case, only 3, but the number of elements in the X have 4, which is fine, right? Less than or equals number of elements of domain. The number of elements in range less than or equals number of elements in the domain. So whether this relation represents a function, let's see, each element of X only one arrow going out, right? So yes, it is a function. So let's see figure 8. What is the domain? 0.70, 0.71, 0.75, 0.78, right? That's 4 elements in X. The range 1529, 1575, 1765, 1798, 1952. Okay, so you see there are 5 elements in the range, but 4 elements in the domain. So from the number of elements, we can tell this is not a function. And then let's see for these elements, 1 element in X paired with 2 elements in Y, right? So that also confirms this relation is not a function. So let's try some other examples. Okay, earlier we see the map. What if given relation represented by order pair, okay, like a point order pair, how can we determine whether relation is a function or not? All we need to do is checking whether we have repeated X or not. Okay? If any X value repeated in a given order pair, let's see, A, 1, 2, 3, 4. Okay, all the X value different, so this will be a function. Okay, find the domain and the range. Domain, it will be 1, 2, 3, 4. Right? The range will be 4, 5, 6, 7. That's for A. And then this is a function. Let's look at the B. Okay, we find the domain and range first and then determine whether it's a function or not. Domain 1, 2, 3, 6, all the value of X, right? 1, 2, 3, 6. And then the range, all the value of Y is 4. And then here have another 4. Repeated value, we don't write a 4 2 times, only write 1 time. Okay, no repeated value. 4, 5, 10. Okay, so whether this is a function, we only look at the X value, whether have repeated one. no repeated, all distinct value of x. So yes, it is a function. Let's look at the C. Domain. We have -3, -2, 0, 1, and then -3. Again, repeated value we don't write. Okay, we don't write it twice, we only write one time. Why? Because set notation is required no repeated value. Okay, all the objects must be distinct. And then range, all the y's, right? 9, 4, 0, 1, 8. That's all the y's. So whether this represents a function or not, so from the number of elements in the domain and the number of elements range, we know this is not a function, right? Because range, we have 5 elements more than number of elements in the domain. So we have 1x, which is -3, pairs with 2 y's, right? 1, 8, 1, 9. So that's not matching function definition. So this is not a function, okay? The relation, C relation, is not a function. All right, what if given your equation, how to determine whether equation is a function or not? So all we need to do is solve for variable y and see 1x pairs with how many y? Okay, all we need to do is solve for the x. So let's see how can we solve this equation. So first we need to subtract x squared from both sides, right? So y squared equals 1 minus x squared. And then in order to solve for y, we square root both sides. So y equals, remember square root method, there are 2 solutions, right? Plus or minus square root of 1 minus x squared. So plus or minus, that means y equals positive square root of 1 minus x squared. The other one is y equals negative square root of 1 minus x squared. So obviously, any given value of x, we have 2y paired with it, right? One positive, one negative. And then that means this relation is not a function. Okay, if 1x pairs exactly 1y, and then it's a function.